Okay, guys, today we're going to talk about the natural log function, and we're going to differentiate. So we're going to go back to, we haven't done any differentiation since last semester, but we're going to differentiate natural logs today. So here's the thing is, you can read this general power rule. Okay, we've talked about that before. That's, it's the integral of x to the n dx is going to be x to the n plus 1 divided by n plus 1 over, or plus c. Okay, but that doesn't work when n equals -1. So basically, we could easily integrate any polynomial as long as we didn't have this, the integral of 1 over x dx, or the integral of x to the -1 dx. Because when we use the power rule on that, remember we bumped the power up to 1, well that would be 0. And anything to the 0 power is 1, and so this doesn't apply to that. So how do we figure this out? Well, definition of the natural logarithmic function. So the natural logarithmic function is defined as this. The natural log of x is the integral from 1 to x of 1 over t dt, where x is greater than 0. The domain of the natural logarithmic function is a set of all positive real numbers. So remember, the natural log function looks like this. Okay, where this is 1, and 1 here, this would be e. Okay? So, properties of natural logs. The natural logarithmic function has the following properties. The domain is 0 to infinity, because it looks like this. It's not defined when it's negative, so it's 0 to infinity. The range is -infinity to infinity, okay? Obviously, it goes to -infinity because there's a vertical asymptote right here. And this, people think that this levels off, but it doesn't. It gets as big as you want. It just takes a long, long time to get there. The function is continuous and increasing in 1 to 1, and the graph is concave downward. Okay, so some properties from pre-calculus. If a and b are positive real numbers and n is rational, then the following properties are true. The natural log of 1 is 0. The natural log of a times b is the natural log of a plus the natural log of b. That was an important one that we used a lot. The natural log of a to the n is n times the natural log of a. And the natural log of a over b is the natural log of a minus b. So that should all be review for you. Okay, so then we did some expanding of logarithms last year. So this would be, since this is division, this would be the natural log of 10 minus the natural log of 9. This one here, since I can rewrite this as the natural log of 3x plus 2 to the 1/2 power. Now I can take the 1/2 down. This is 1/2 the natural log of 3x plus 2. Now remember, you cannot expand this because you can't expand addition or subtraction. You can only expand multiplication or division. Okay, the natural log of 6x divided by 5. This is going to be the natural log of 6 plus the natural log of x, because those are being multiplied, minus the natural log of 5 that's being divided. And over here we got this really complicated one, okay? So we can break this down. We've got 2 natural log of x squared plus 3, which I can't break up because of the addition, minus, because this is being divided, everything down here has got to be minus, so this is the natural log of x, minus 1/3 the natural log of x squared plus 1, which I can't break up because of the addition. There's just a little quick review for you on expanding logarithms. Okay, the letter e denotes the positive real number such that the natural log of e is the integral from 1 to e of 1 over t dt is equal to 1. Okay, remember natural log and e to the x power cancel each other out, and e comes out to be the number 2.71828182846, and so on forever. It's like pi, it goes on forever and never repeats. The derivative of the natural log. Okay, so here we're getting to the meat of it today. Let u be a differentiable function of x. The derivative of the natural log of x is 1 over x. Okay? And the derivative of the natural log of u, where this is some kind of composite function, is 1 over u du dx, or sometimes it's written as u prime divided by u, the derivative of u over u, where u is greater than 0. Okay, so here we go. We're going to talk about derivatives. So the derivative of the natural log of 2x. Okay, so not very difficult. So that's going to be 1 over 2x times the derivative of the inside. I got to use the chain rule. So times 2, which means that the 2 and the 2 are going to cancel out, and I'm just going to get 1 over x. Okay, the derivative of the natural log of x squared plus 1. So this is going to be 1 over x squared plus 1, because that's the derivative of the natural log, but I got to use the chain rule, so it's times 2x, and that's just going to be 2x over x squared plus 1, and I really can't simplify that, so I'm done with that one. Okay, next up. The derivative of x times the natural log of x. Okay, this is a multiplication problem. You got to remember that you must use the product rule here. So it's going to be the derivative of x, which is 1, times natural log of x, plus x times the derivative of the natural log, which is 1 over x. And this ends up being natural log of x plus 1. Okay, on this one, we've got the chain rule coming up here. So the derivative of the natural log of x to the 3rd power. Okay, so this is going to be, we're going to use the power rule. It's going to be 3 natural log of x squared. We drop the power one. Times the derivative of the inside, because it's the chain rule, so that's going to be times 1 over x. And then we can kind of clean that up and make it 3 natural log of x squared over x. Okay. Moving right along. All right. Using logarithmic properties as aids to differentiation. So what we're going to do here is we're going to go ahead and rewrite this function as the natural log of x plus 1 to the 1/2 power. And then remember, I can use my logarithmic properties. I can take the 1/2 down. So this is 1/2 the natural log of x plus 1. And then if I want to differentiate that, f prime of x is just going to be 1/2 times the derivative of this, which is going to be 1 over x plus 1. Now, really, we use the chain rule because we've got a function inside a function, but the chain rule, the derivative of x plus 1 is just 1, so I don't really have anything to do here. So this would be 1 over 2x plus 2. All right, what do we do with this mess? f of x is the natural log of x times x squared plus 1 squared divided by the square root of 2x cubed minus 1. All right, here's what I would do. I would use properties of logarithms to break this thing up into as many pieces as I could. So f of x is going to be the natural log of x plus 2 times the natural log of x squared plus 1 minus 1/2 the natural log of 2x cubed minus 1. Okay, now I can differentiate these three parts much easier. Okay, the derivative of natural log of x is 1 over x, plus the derivative of this is going to be 2 times 1 over x squared plus 1 times the derivative of this, which is going to be 2x, minus 1/2 times 1 over 2x cubed minus 1. Oops, got a stray parenthesis there. Times the derivative of this, which is going to be 6x squared. And now it's just a matter of cleanup. That's the answer. We're just going to make it look pretty now. So this is going to be 1 over x. This is going to be plus 4x over x squared plus 1. Minus, the 2 is going to cancel the 6 and put a 3x squared on the top over 2x cubed minus 1 on the bottom. And there we have it. Okay, so what do? We took this really complicated natural log problem, we broke it up into pieces using properties of natural logs, and then we differentiated each of the pieces and added them together. Okay, so don't forget to use a chain rule when you're doing derivatives. Okay, this one here is a bit more complicated. Okay, so this is a problem where we're going to use natural logs even though there's not a natural log in the problem to differentiate this thing. So what we're going to do is we're going to natural log both sides of this thing. And the reason we're going to do that is because if we use natural logs on this over here, then we can break this thing up into a whole bunch of easier problems. You know what? Let's rewrite this right here as x minus 2 squared times x squared plus 1 to the negative 1/2. Okay. Now, here's where it's a little bit tricky to get here. All right. Now, since this is not in terms of x, we're going to write this as, when we differentiate this is going to be, so what we're going to do is we're going to take, oops, the derivative of both sides of this. Okay? Now, this side here is going to be 1 over y times the derivative of y. Okay, this over here, you know what I should do first though, before I do this? Let's break this thing up. So this is natural log of y is equal to 2 natural log of x minus 2 minus 1/2 the natural log of x squared plus 1. Okay, so by doing that, that's going to make it easier to differentiate. So now we're going to take the derivative of both sides. Okay, we're going to end up with y prime over y on this side. Over here, this is going to be 2 times 1 over x minus 2 minus 1/2 of 1 over x squared plus 1 times 2x. Okay. Now, we got a couple things going on here. That's going to cancel this. And so this is going to be y prime over y is 2 over x minus 2 minus x over x squared plus 1. All right, now we got a problem here because we want y prime, but we've got this y right here. So let's first move it to the other side. We're going to multiply both sides by y. So this is y prime is y times all this stuff over here. And you might ask yourself, how does this help me? I still have a y in here. Well, I know what y is. Y is this stuff. So I can take this right here, and I can take it down here, and I can substitute it in for y. So then y prime, that's the derivative that we wanted. That's going to be x squared, or x minus 2 squared over, what is it, square root of x squared plus 1 times this stuff right here, 2 over x minus 2 minus x over x squared plus 1. And now we have a derivative. And you could clean that up a little bit. You know, you could distribute this inside of here. Essentially, that's the answer, though. I don't know. I suppose you could, if you distributed this in here, this would cancel one of those, and so you'd have 2 times x minus 2 over the square root of x squared plus 1. And over here, you'd have x times x minus 2 squared, and this is x to the 1/2, or that's x squared plus 1 to the 1/2, and that's x squared plus 1 to the 1, so this is going to be x squared plus 1 to the 3/2 power. And I suppose if you really wanted to, you could get this into one fraction, but we're going to leave it at that. Okay, derivatives involving absolute values. So this is getting a little bit tricky here. I feel like I missed a page here. Oh, okay. So if if u is a differentiable function of x such that u is not equal to 0, then the derivative of the natural log of the absolute value of u is equal to 1 over u times the derivative of u. Okay, so let's use that property to find the derivative of f of x is the natural log of the absolute value of cosine of x. Okay, so if you remember, we'll just copy it from the previous page. Okay, the derivative of the absolute value of the natural log of the absolute value of x is 1 over x times 1 over x times x prime. Okay, so what we're going to do here is we're going to take the derivative of this. This is going to be the derivative of cosine, which is going to be sine in this case. Let's see, wait, the derivative of cosine is negative sine, so it's going to be negative sine. And then the bottom is going to be cosine. And that, my friends, is also known as the negative tangent of x. And you're done. Okay. Finding relative extrema. Okay, so if you remember back to last semester, you found the relative extrema of something by finding the derivative and setting it equal to 0 and solving it, okay? So we would find the derivative of this. So y prime would be 1 over x squared plus 2x plus 3 times the derivative of that, which would be 2x plus 2. Okay, so there's my derivative. I need to know when this is 0. Well, it's going to be 0 when the numerator is 0. So when 2x plus 2 is 0, 2x is negative 2, x is negative 1. All right, so that's where the relative extrema is going to be, is when x is negative 1. And then I can just plug that in there, and I find out that the natural log of negative 1 squared plus 2 times negative 1 plus 3, this is going to be the natural log of 1 minus 2 plus 3, which is just going to be the natural log of 2. So my relative extrema is located at negative 1 natural log of 2. And there we have it. So pretty short lesson today. Here's the problems I want you to take a look at, and I'll see you next class.